My name is Awasthi and I'm starting a new physics series for ICSE Class 9 students. The mode of delivery will be English since we are catering to ICSE students. The best part of this lecture series is going to be the physical relatability of the topic. You're going to see physics around you, right? Let me introduce myself. My name is Awasthi. I've already told you. I have done my masters and my BTech in electronics and communication engineering, and I have been teaching physics since 2008. So I have a teaching experience of more than 14 years, right? So without wasting any time, let us start with the very first lecture of ICSE Class 9 Physics. The topic for the day is system of units and the units in SI systems. And like I said, we are going to relate the topic with the real world. So it's better to learn measurement through this very relatable example, right? I'm sure many of you might have seen these two guys in advertisements, in televisions. You have seen them, and they come in the advertisement of 5-star. And what that advertisement says, let me just tell you. They visit a place and they ask the tailor in Hindi, पिताजी की पतलून एक बिलांग छोटी कर दो, right? So bilang is like this is a local way of measuring length. So what they do is they tell the tailor and they ask him to reduce the length of the pant by 1 bilang. Now many of you might not be aware of this 1 bilang or maybe 1 balis. You know, it's a very local kind of a language and it varies from place to place. But yes, I guess all of us at some point of time have used these methods to measure things, right? When we were kids, in fact we all are still kids, you guys are still kids. When you measure your height, you compare your height with your friends, what you do, you and your friend, you stand on the corner of the wall touching your backside with the wall and you count your height, and you end up saying my height is 3.5 of this hand. Now tell me, can I use this method as a standard method for measurement? See, the length of my hand, my palm is different from the length of your palm. Obviously, as we grow up, this length increases. So this measurement cannot be taken as a universal measurement. The same goes with foot. At times when we play cricket, or maybe many of you might be drawing the crease of the the batting pitch through your bat, the handle of the bat. You measure full bat and then you measure half more and you say, sir, this is the crease, this is the batting crease. Now just tell me one thing, do all the bats measure the same length? No, they don't. So these are few methods that we have been using all those while for measurement, but they cannot be regarded as a standard method of measurement. And measurement in physics is very, very, very important. Unless you are able to measure a physical quantity, you're not going to analyze it further, right? I have used a word physical quantity, so a lot of you might be unaware of this word. It sounds very familiar, but technically speaking, there is a lot of technical aspect into this. See, any quantity that can be measured is a physical quantity. If I ask you how happy you are, how sad you are, how much you love your parents, you will say, sir, I love my parents a lot, I'm very sad, I'm very happy. But if I ask you to quantify this happiness, sadness, love, sorrow, hatred, you will not be able to tell me a quantity. You will never say, sir, I am 10 to the power 10 times happy. No. Why? Because happiness, sorrow, these are not physical quantities. Any quantity that cannot be measured is not a physical quantity. We can measure a physical quantity, and we'll be measuring all those physical quantities in this first part of your syllabus. I guess I'm pretty clear to all of you what measurement is. In measurement, we measure a physical quantity, but the next question is, how do we measure it? I mean, how do you measure something? If I say that your weight is 42 kgs, let me say the person who is watching this lecture right now weighs 42 kg. Now tell me, where does this figure come from? There must be someone in the world, someone in the universe who has told us, okay sir, this is 1 kg and I am 42 times of this 1 kg. That is why my weight is 42 kg. You're getting my point? Sir, the road is 5 kilometers long. Somewhere at any point of time, you know what is 1 kilometer. That is why you are able to say that the distance, the length of this particular patch of the road is 5 kilometers. So while measuring physical quantities, we must have a standard value. That is what I meant to tell you. You cannot measure a physical quantity without a standard value. So technically speaking, what is measurement? Measurement is the process where you compare a given quantity with some standard quantity, right? Now, whenever you are measuring anything, for example, let us say that you are measuring 42 kgs. So here you can see that 42 is the numerical value and this kg is the unit. If I'm not writing kg with 42, you're never going to understand that we are measuring mass, or rather we are measuring weight. Weight is a force rather, so we'll call it mass, right? Unless we are specifying kg with 42, you won't be able to, decide what physical quantity we are actually measuring. That is why your teacher was telling you all these years, you have to write units in the answers. Without units, the answer is incorrect. If I say 42, now this has no physical meaning, right? It can be 42 kg, it can be 42 liters, it can be 42 kilometers. But as soon as you see this kg, liter, kilometer, you instantly draw a conclusion. Okay, sir, 42 kgs is mass, 42 liters is volume, 42 kilometers is length, right? So every measurement is attributed by two very distinctive qualities. One is the unit, which tells you that which physical quantity you are actually measuring, and the second one is the numerical value, which tells you how many times the selected quantity is in comparison to the standard quantity, right? 42 kg means this physical quantity is 42 times of 1 kg. So what is a physical quantity? It is a combination of a numerical value and a unit. I guess I'm pretty clear, right? Now, every measurement has to have some characteristics, right? The very important one is every unit should have a convenient size. Now, if I ask you to tell me the weight of an elephant in grams, I mean, is this a convenient size? Let us assume that the elephant that we are talking about is of 200 kgs. Now, is it good enough to tell me that, sir, the weight of the elephant is 2 lakh grams? Is it a convenient size to measure the weight of an elephant? I guess no. Rather, I should say, sir, the elephant weighs 2 quintals, right? So we have to select the unit very properly. It has to be of convenient size, right? I mean, you will never say that, sir, my school is itna meters away from my house. We normally use kilometers for that, right? This is the very first characteristic that every unit should have. The second one is the unit should be defined without any ambiguity. There has to be no confusion when you are defining a particular unit or you are using a unit to define something. For example, if I start measuring volume in a different unit which is not very popular, will it be good enough to measure it? I mean, will it be easily understood by everyone? I guess no, right? It's not a very good idea to measure it in meter cubes. We normally do it in liter, right? Meter cube also works, but there are other units as well. So we have to very smartly select a unit so that there is no confusion in that unit. Third one it has to be reproducible. Now what does this reproducible means? If I'm using a unit, the other person should change it accordingly. For example, I have used a unit 200 kg, and you know that kg can easily be converted into a more appropriate unit, that is quintals. So reproducibility is again a very important aspect for measurement, right? And the last one is super duper important. The unit should not vary with respect to space and time. For example, you are traveling, see, I am from Lucknow. For example, I am traveling from Lucknow to Bengaluru, right, via road. As soon as while I am traveling, while I am driving in Uttar Pradesh, Lucknow is in Uttar Pradesh, all my signboards are showing me distance in kilometers. As soon as I cross UP, maybe I enter MP or some other state, all of a sudden the signboards start reflecting the distances in miles. Now is this a good idea? I mean, half the journey I'm viewing the signboards with distances written in kilometers, and then all of a sudden with space I come across a different kind of unit. So this is not a very good idea. Okay, you might have seen that in India we prefer kilometers in all the signboards. In European countries they use miles. You're getting my point? So you should not change the unit within a given boundary. That has to be again a very, very important property and characteristic, right? Now there are three basic systems of units that we use. First is MKS, that is meter, kilogram and second. This is the first one. The second one is British system, feet, pounds and seconds. And the third one is French system, CGS, that is centimeters, grams and seconds, right? So these are three basic systems. Is that very, very clear to all of you? Let me write it: foot, pound, second, and now this is like centimeter, grams and seconds. So these are three basic units that are used, everyone. But apart from these three units, we have one more system. Apart from these three systems, we have one more system that is called SI system, system of international units, system of international units, right? Now this SI system has proposed 7 fundamental quantities and 2 supplementary quantities. Now before we dwell into this fundamental unit and quantity part, let me just tell you, in measurement, like I said a while ago, you need certain standards, right? Now we measure infinite number of quantities. The quantities that we measure are, very great, very large in number. So how to set the standards? I mean, how to set the standards? That is a very, very big challenge. So to solve this problem, it was decided that we have 7 fundamental quantities, and all the other quantities which we derive from these fundamental quantities will be called derived quantities, right? Excuse me. The units of these fundamental quantities are fundamental units, and all the other quantities, the derived quantities, will have the units that we'll call derived units. So these are 7 fundamental quantities: mass, length, time, temperature, luminous intensity, electric current and amount of substance. And this is the unit of these respective quantities along with the symbol. So guys, this is the first time, if you are a class 9 student, I'm sure this is the first time that you are coming across the fundamental units and quantities in detail. So at this point of time, I would suggest you have to learn these 7 fundamental quantities. There is no other option. The 2 supplementary quantities are angle and solid angle. These are 2 supplementary quantities. Angle, the unit is radian. Solid angle, the unit is steradian, right? So these are 2 supplementary quantities. And apart from these quantities, all the quantities that you come across, they are all derived units. I have taken few of them if you guys are following Selena, there is a table in the book which has 16 derived quantities, and you have to have a basic idea of what these quantities are, right? So I will not ask you to learn the chart instantly. As we'll be proceeding in the syllabus, as we'll be learning new and new formulas, you'll automatically learn the entire chart, right? So for your first term examination, whatever your teacher is telling you, just learn those. By the time we end this playlist, by the time we finish the entire syllabus, you will be able to memorize everything. Is that very clear? Now, apart from these quantities, there are certain prefix and suffixes. See, there are certain quantities which can be changed into a, which can be rather scaled into a larger quantity or maybe a smaller quantity. If I say ohms, ohms is the unit of resistance. I'm sure in 6th, 7th, 8th you must have come across ohm, right? Or for that matter, kg. I guess all of you know kg is mass. If I say milliohm, see, milliohm, milli is like 10 to the power minus 3. If I say mega ohm, so mega is 10 to the power 6. So at this particular point of time, you have to learn this. This is the first time that you guys are, coming across these values. So you have to learn this chart. I have made it very simple for you, and I have taken only those quantities that will be used, right? The chart is very long, but there is no need to memorize everything, right? This would do. Now let's talk about three fundamental quantities. See, in class 9th, we'll be dealing with these three only: mass, length, time. In class 9th ICSE, you don't have to be, extra cautious about the other physical quantities. Only these three physical quantities are in your syllabus. So we'll be starting with length. The SI unit is meter. Now you can clearly see that I have used a different ink. Why? See, if you are quoting something which is a standard definition, you cannot use it in your own words. You cannot define meter in your own words, right? This system, SI system, it has predefined definitions of these standard quantities which have to be followed. So be it length, be it mass, be it time, you have to learn these basic units, basic definitions word by word. There is no other option. Okay, is that very clear? Clear to all of you? I guess yes, right? So this is the basic definition, right? Like I said, you have to learn this. There is no other option. Now, meter is the SI unit of length. There are other bigger units as well. See, few distances are very large and cannot be measured in meters or maybe kilometer rather. So we have few non-metric units as well. The very first being astronomical unit, AU. This is the very first unit, which is again a non-metric unit, right? What is 1 AU? 1 astronomical unit is the mean distance between Earth and Sun, right? And see, since Earth and Sun, they are fixed, so this mean distance has to be fixed as well, right? You cannot have a different mean distance every time, because the position of Earth and Sun relative to each other are always fixed. So this is 1 AU. You have to learn this value. 1 AU is 1.496 into 10 to the power 11 meters. Similarly, you have one more unit, that is light year. Now, what is light year? Light is the it is the distance traveled by the light in vacuum in 1 year. Now, what is the speed of light? All of us are aware that the speed is 3 into 10 to the power 8 meter per second. So how will you calculate this distance? Distance is equal to speed into time. Time is 1 year. 1 year is how many seconds? 1 year is 365 days. 1 day is 24 hours. 1 hour is 60 minutes and 1 minute is 60 seconds. So if you will be multiplying these quantities, you will be getting this value, right? So light year, see why light year is important. It seems as if light year is a unit of time, but no, light year is the unit of distance. That is why it is important. Okay, like light years, if I convert this into say minute, second, so this will give you light minute and light second. This is very easy. We'll be doing questions on that. Right now, this par second, now this sometimes is very confusing. You will not find a proper explanation in many books. What is 1 par second? Again, it has seconds in it, but still it is a unit of distance. Now see, the position of sun and earth is fixed, and you know that this distance is nothing but 1 AU. The distance between sun and earth we have just discussed. Astronomical unit is the distance between sun and earth. Now this is some point, okay, and this is the semi major axis. Now the distance at which this semi major axis subtends an angle of 1 second, that distance is called 1 par second. In class 9th you just have to learn it, but to make it more relatable for you, I have shown you this pic. Right, few smaller units as well. I have taken in this session only those units which you will be using very frequently throughout the course. So angstrom and Fermi, these are two units which we'll be using very frequently. Similarly, for mass, the SI unit is kg. Again, this is the definition of kilograms, which is a standard definition, and you have to mug it up, right? The other being grams, milligrams, quintal. 1 quintal is 100 kg, 1 metric ton is 10 quintal. Okay, these are those units. Again, non-metric unit. Non-metric is a bigger unit. Like I said, we have non-metric unit for distance, we have non-metric units for mass as well, right? So for mass, the non-metric unit is unified atomic mass, AMU. 1 AMU is 1 by 12th part of 1 C12 atom. Okay, so when you will be solving it, you will be getting 1.66 into 10 to the power minus 27 kg. Now the question is, sir, where does this figure come from? Okay, so let me explain. Avogadro number, we will be using Avogadro number. Avogadro number has, you know, this is related more of a mole concept. Okay, so you have to understand what Avogadro number is. The value of Avogadro number is 6.023 into 10 to the power 23. So the mass of Avogadro number of particles is 12 grams. So mass of 1 is 12 upon 6.023 into 10 to the power 23. This is for one atom. So 1 by 12th part will be 1 by 12th part will be 1 by 12 into 12 into 6.023 into 10 to the power 23. This 12 will get cancelled and you will be getting this value. Right, now one more thing, it goes the same way like we had unified atomic mass. We have one more unit which we call as solar mass. Okay, again you have to learn this, solar mass, and the value is 2 into 10 to the power 30 kg. Okay, this is again a non-metric unit of mass. The unit of time is seconds. These obviously are the definitions for the standard values which you have to learn. Now other units, minutes we know, hour, day we know, lunar month. Now lunar month, this you might have heard in Muslims they follow lunar calendar, right? So a lunar month has 29.5 days. Month, year, leap year, February will have 29 days, right, in a leap year every 4 years, and you will have 366 days in the leap year. Decade, 10 years, century, 100, 1000. So these are very basic things. Now there are certain guidelines which we follow while writing the units. This is just a theoretical part. You won't be asked about this in your exams, but since it is mentioned in your textbook, so you have to have a very basic idea. I'll explain you very quickly. if you are naming a unit which is not by the name of a scientist, you have to use a lower case, right? Like dyne. Dyne is a unit of force. On the contrary, you have one more unit of force, that is Newton. In Newton you use capital N. Why? Because you are using the name of a scientist. Okay, so while you change the notion, the way of writing the unit changes. So this discusses point 1, 2, right? Whenever you are combining two units, for example, I say Newton meter, so you have to either put a small dot or a dash between the two. Okay, this again is an important point. These are few points that you have to learn. It's very basic, right? So this brings us to the end of the first part of the first session. Question. This is the first question. The question says the size of a bacteria is 1 mu. सबसे पहले 1 mu is equal to 10 to the power minus 6 meter. मैंने लास्ट क्लास में आपको एक चार्ट पढ़ाया था. दिस वाज द चार्ट. इफ यू रिमेंबर, अगर आप क्लासेस को फॉलो कर रहे हो तो दिस वाज द चार्ट एंड दिस इज म्यू. आप देख रहे हो, दिस इज म्यू. तो मेरा क्वेश्चन कह रहा है दैट द साइज ऑफ द बैक्टीरिया इज 1 म्यू, दैट इज 10 to the power minus 6 meter. You have to find the number of bacteria in 1 meter length. अब देखो, बहुत से बच्चों को कंफ्यूजन रहता है कि सर इसमें मल्टीप्लाई करें कि डिवाइड करें. तो मैं आपको बहुत सिंपल तरीका बताता हूं. देखो, आपको 1 मीटर लेंथ में बैक्टीरिया निकालना है. मान लो ये 1 मीटर लेंथ है, ठीक, दिस इज 1 मीटर लेंथ, और इसमें बहुत सारे छोटे छोटे बैक्टीरियाज हैं. क्वेश्चन कह रहा है कि एक बैक्टीरिया 1 माइक्रोन का है, तो कितने बैक्टीरिया हैं? लेट वी हैव n बैक्टीरियाज. देखो, जब कभी भी आपको कंफ्यूजन हो, आप क्लास 9th में हो, अभी हो सकता है कंफ्यूज हो जाओ, सर इसमें मल्टीप्लाई करना है या डिवाइड. तो मैंने मान लिया कि 1 मीटर लेंथ में n बैक्टीरियाज हैं. एक बैक्टीरिया का साइज कितना है? 1 माइक्रोन. तो टोटल लेंथ में कितने बैक्टीरिया होने चाहिए? 1 माइक्रोन इंटू n, और ये किसके बराबर होना चाहिए? 1 मीटर के बराबर होना चाहिए. अच्छा, राइट हैंड साइड पे मीटर है, लेफ्ट हैंड साइड पर माइक्रोन है, तो मुझे यूनिट चेंज करनी पड़ेगी. इंटू n इज इक्वल टू 1. तो n का वैल्यू कितना आ जाएगा? 1 डिवाइडेड बाई 1 इंटू 10 टू द पावर माइनस 6. इसकी वैल्यू आ गई 10 टू द पावर माइनस 6. अब बहुत से बच्चे यहां पर यूनिट लिखने लगते हैं. बेटा, नंबर की बात हो रही है, ठीक है ना, हम लेंथ नहीं बता रहे हैं. हम आपसे पूछ रहे हैं कि 1 मीटर लेंथ में कितने बैक्टीरिया हैं, तो इसकी यूनिट नहीं होगी, ये एक नंबर है. ठीक है, आई होप आपको इस ट्रिक से कभी कंफ्यूजन नहीं होगा कि सर मल्टीप्लाई करना है या डिवाइड करना है. ठीक है ना. चलो एक और क्वेश्चन करते हैं. द डिस्टेंस ऑफ अ गैलेक्सी फ्रॉम अर्थ इज 5.6 इंटू 10 टू द पावर 25 मीटर. ठीक है ना. आपको जो डिस्टेंस दिया है दैट इज 5.6 into 10 to the power 25 meters. Okay, assuming the speed of light is, speed of light को बच्चा हम लोग small c से represent करते हैं. ये अभी से ध्यान रखना and make sure that you remember it, right? We'll be representing the speed of light through c, and the value of c is 3 into 10 to the power 8 meter per second. In case the value is not given, even then you have to remember this value. And the question is saying find the time taken by the light to travel this distance. Now we know that distance is equal to speed into time. So what will be the value of time? Time will be distance upon speed. Distance is 5.6 into 10 to the power 5 and speed is 3 into 10 to the power 8. So this will be 1.8 into 10 to the power 17 seconds. अब बच्चों, आई एम श्योर मेनी ऑफ यू, ऑलमोस्ट ऑल ऑफ यू नो दिस, बट इन केस अगर किसी को ये ऑपरेशन करना नहीं आता है तो मैं एक बार बता दूं. अगर कभी भी 10 to the power 8 डिवाइडेड बाई 10 to the power b आ रहा है, इट मीन्स यू हैव टू डू 10 to the power a minus b. ठीक है ना. तो 10 to the power 25 divided by 10 to the power 8 will be 10 to the power 25 minus 8. So this will be 10 to the power 17. So that is why I have written 10 to the power 17. I hope the logic is clear. और यहां पर मैंने क्या किया हुआ है, मैंने 5.6 को 3 से डिवाइड किया हुआ है. देखिए अगर आपको किसी भी टॉपिक में किसी भी पार्ट में छोटी सी छोटी प्रॉब्लम भी है तो यू आर फ्री टू टेल मी इन द कमेंट सेक्शन. आई विल बी मोर देन हैप्पी टू हेल्प यू आउट. बिल्कुल हेजिटेट नहीं करना है. आई नो मेनी ऑफ यू could not study properly during the COVID time. 6th 7th 8th बहुत अच्छे से नहीं गया है तो हो सकता है आपका बेसिक थोड़ा सा वीक हो, बट कोई टेंशन की जरूरत नहीं है. यहां पर हम सब कुछ कवर करवाएंगे फ्रॉम वेरी बेसिक. छोटे से छोटा कैलकुलेशन भी आई विल बी डूइंग इट फॉर यू, राइट. तो आपको न्यूमेरिकल्स में कोई प्रॉब्लम नहीं होगी. नेक्स्ट क्वेश्चन. द वेवलेंथ ऑफ द लाइट इज 589 नैनोमीटर. सबसे पहले बच्चों वेवलेंथ को हम लैम्डा, right, we have a symbol called lambda. This is how we represent wavelength. It's lambda, right. So हम हमेशा wavelength को lambda से लिखेंगे. The value of lambda is 589 nanometers and the question is saying you have to express it in angstrom. This is angstrom. Again बच्चों if you have watched the previous session मैंने already chart आपको दिया हुआ है एंड मैंने क्वेश्चंस भी इसी हिसाब से लिए हैं कि आपको वो चार्ट याद रहे. एंगस्ट्रॉम, सी दिस इज एंगस्ट्रॉम. ऑलरेडी मैंने एंगस्ट्रॉम को इनकॉर्पोरेट किया हुआ था. ठीक है ना बच्चों, तो कोई टेंशन नहीं है, आराम से पढ़ेंगे. 100% क्वेश्चन होगा ये. दिस इज नैनो. नैनो भी आपके चार्ट में है. अब यहां पर कंफ्यूजन हो जाएगा, सर हमें तो हर चीज मीटर से कन्वर्ट करनी आती है, अभी नैनो को एंगस्ट्रॉम में कैसे कन्वर्ट करें. कोई टेंशन नहीं है. अगर आपको नैनोमीटर और एंगस्ट्रॉम नहीं मालूम है तो आपको मालूम है 1 नैनोमीटर इज इक्वल टू 10 टू द पावर -9 मीटर, राइट. फाइन. तो 1 मीटर कितना हो गया, 1/10 टू द पावर -9 नैनोमीटर. अच्छा, नेगेटिव पावर जब ऊपर जाएगी तो प्लस हो जाएगी, तो दिस इज 10 टू द पावर 9 नैनोमीटर. अब 1 एंगस्ट्रॉम इज 10 टू द पावर -10 मीटर्स, राइट. तो 1 मीटर इज इक्वल टू 1/10 टू द पावर 10 एंगस्ट्रॉम. तो दिस इज 10 टू द पावर 10 एंगस्ट्रॉम. इज दैट क्लियर. अब लेफ्ट हैंड पे यहां पर भी 1 मीटर है, यहां पर भी 1 मीटर है. इसका मतलब ये राइट हैंड साइड वाली चीजें भी बराबर होनी चाहिए. दैट मीन्स 10 टू द पावर 9 नैनोमीटर शुड बी इक्वल टू 10 टू द पावर 10 एंगस्ट्रॉम. तो 1 नैनोमीटर शुड बी इक्वल टू 10 टू द पावर 10 डिवाइडेड बाई 10 टू द पावर 9 एंगस्ट्रॉम. तो 1 नैनोमीटर शुड बी इक्वल टू 10 एंगस्ट्रॉम. अब देखो मुझे नैनोमीटर और एंगस्ट्रॉम में रिलेशन मिल गया. अब कोई टेंशन नहीं है. मुझे 589 नैनोमीटर दिया हुआ था तो 589 नैनोमीटर में होंगे 10 इंटू 589 एंगस्ट्रॉम. दिस विल बी 5890 एंगस्ट्रॉम. इज दिस वेरी वेरी क्लियर. वीडियो को पॉज करो और यहीं पर ट्रिक को समझो. देखो, whenever you are asked to convert one unit into other unit and you don't know the conversion, always select a more popular unit. अभी यहां पर नैनोमीटर से मीटर का कन्वर्जन आपको मालूम है, एंगस्ट्रॉम से मीटर का कन्वर्जन आपको मालूम है. दोनों वैल्यूज मैंने लिख ली और दोनों को इक्वेट कर दो तो you will get the desired result. This is my desired result. Is that very very clear? So बच्चों फटाफट से वीडियो को लाइक कर दो अगर आपको ये अच्छा लगा एंड शेयर इट विद योर फ्रेंड्स. ठीक है ना. ऐसी बहुत सारी ट्रिक्स मैं बताऊंगा आपको न्यूमेरिकल करने में. क्लास 9th में ही आपको न्यूमेरिकल्स बहुत इजी लगने लगेंगे. चलो अगला क्वेश्चन करते हैं. द मास ऑफ ऑक्सीजन एटम इज 16 U and you have to find the mass in kg. अब this question has also been selected deliberately ताकि आपको ये U वाली पार्ट पता चल जाए. This is देखिए 1 AMU एटॉमिक मास यूनिट, वी कॉल इट एटॉमिक मास यूनिट। ओके, इसी को हम एक नाम और देते हैं, दैट इज यूनिफाइड एटॉमिक मास यूनिट। एटॉमिक मास यूनिट को हम AMU से लिखते हैं एंड यूनिफाइड एटॉमिक मास को हम U से लिखते हैं। दोनों का बच्चों एक ही मतलब होता है एंड दिस इज अ नॉन मेट्रिक यूनिट ऑफ मास। अब क्वेश्चन ये आता है सर नॉन मेट्रिक यूनिट्स क्या हुई? नॉन मेट्रिक यूनिट्स का मतलब हुआ वो यूनिट जहां पर बहुत ज्यादा वैल्यू इन्वॉल्व होती है। तो 1 AMU क्या होता है? एक बार वैसे मैंने आपको लास्ट क्लास में बताया था, बट फॉर द स्टूडेंट्स हु आर जॉइनिंग अस फॉर द फर्स्ट टाइम, 1 AMU इज द 1/12th पार्ट ऑफ द मास ऑफ 1 C12 एटम। ठीक, कार्बन 12 एटम के एक मास का, एक एटम का जो मास है उसका 1/12th पार्ट होता है एंड 1 U और 1 AMU इज इक्वल टू 1.66 into 10 to the power minus 27 kg। दिस इज द रिलेशन। ये रिलेशन है AMU एंड kgs में, राइट? 1 AMU is 1.66 into 10 to the power minus 27 kg। तो बच्चों 16 AMU कितना होगा? तो 16 यूनिफाइड एटॉमिक मास इज 16 into 1.66 into 10 to the power minus 27 kg। इसकी वैल्यू आएगी 2.656 into 10 to the power minus 26 kg। दिस इज गोइंग टू बी द वैल्यू। आप इसको सॉल्व कर लोगे तो यू विल गेट दिस वैल्यू। एक्चुअली आपको मिलेगा 26.56 इंटू 10 टू द पावर माइनस 27। बट जब आप एक डेसिमल को पीछे करोगे तो आपको यहां पर 10 से मल्टीप्लाई करना पड़ेगा, तो यू विल गेट दिस वैल्यू, राइट? देखिए आंसर बच्चों आप लोग ऐसे नहीं लिख सकते, बिकॉज हम ऑलरेडी जानते हैं, अभी आपको दोबारा फिर बताऊंगा, यू ऑलवेज हैव टू राइट योर आंसर इन सिग्निफिकेंट फिगर्स, राइट? अभी आगे के सेशन में आई विल टेल यू व्हाट सिग्निफिकेंट फिगर्स आर, बट एज ऑफ नाउ यू हैव टू अंडरस्टैंड दैट ऑल द आंसर्स हैव टू बी रिटन इन सिग्निफिकेंट फिगर्स। सिग्निफिकेंट फिगर्स में बच्चों डेसिमल ऑलवेज कम्स आफ्टर द फर्स्ट प्लेस, रिमेंबर दिस, राइट? चलो अगला क्वेश्चन करते हैं। It takes 8 minutes for the light to reach from sun to earth. If the speed of the light, again the speed of the light is 3 into 10 to the power 8 meter per second, and how much time does the light take? It takes 8 minutes. अच्छा, यहां पर सेकेंड्स है, यहां पर मिनट्स है, तो यू हैव टू कन्वर्ट इट इनटू सेकेंड। 1 मिनट इज इक्वल टू 60 सेकेंड्स, तो 60 से मल्टीप्लाई कर दिया, यू गेट 480 सेकेंड। नाउ यू हैव टू फाइंड द ऑर्डर ऑफ मैग्नीट्यूड ऑफ द डिस्टेंस। तो डिस्टेंस इज इक्वल टू स्पीड इनटू टाइम, so that is 3 into 10 to the power 8 into 480, right? तो 0 into 10 to the power 8. Is that very very clear? This is meter. If you convert it into kilometers, it will be 10 to the power 8 kilometers, right? Fine. 1 meter is equal to 1 upon 1000 kilometers. ये मैंने यूज किया है. So what is the order of the magnitude? The order of the magnitude is 10 to the power 8. Is that very very clear? चलो. The distance of the star from the earth is 8.33 light minutes. What do you mean by this statement? See, what is light year? Light year is the distance traveled by light in 1 year. So what will be light minute? Light minute will be distance traveled by light in 1 minute, right? तो यहां पर distance traveled by the light in 1 minute is defined as light minutes. Is that very 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 clear? Fine. इसमें किसी को कोई प्रॉब्लम नहीं होनी चाहिए. फाइन है. अगर बच्चों किसी भी पॉइंट पर यू हैव एनी प्रॉब्लम, प्लीज ड्रॉप इन अ कमेंट. आई विल बी मोर देन हैप्पी टू हेल्प यू, राइट? अच्छा, क्वेश्चन का सेकेंड पार्ट क्या कह रहा है? इट इज सेइंग यू हैव टू एक्सप्रेस दिस डिस्टेंस इन मीटर्स. दैट मीन्स यू हैव टू कन्वर्ट लाइट मिनट इनटू मीटर्स. अच्छा, एक बात मेरे को बताओ, व्हाट इज द स्पीड ऑफ द लाइट? स्पीड इज 3 into 10 to the power 8 meter per second, right? What is the distance? You have to find the distance. And what is the time taken? Time taken is 8.33 light minutes. So distance is equal to 3 into 10 to the power 8 into 8.33 light minutes. इतना मिनट लगा, right? एक मिनट में यू हैव गॉट 60 सेकेंड. सी यहां पर यू हैव गॉट सेकेंड्स, तो आपको 8.33 लाइट मिनट्स, 8.33 मिनट्स को भी सेकेंड्स में कन्वर्ट करना पड़ेगा. तो इट विल बी 8.33 into 60 seconds. So light minute is the distance traveled by the light in 1 minute. Okay? Is that very very clear? तो जब आप सेकेंड में कन्वर्ट करोगे, यू विल मल्टीप्लाई इट विद 60. जब आप इसको सॉल्व करोगे तो यू विल गेट 1.5 into 10 to the power 11 meters. So this is going to be your answer. ये क्वेश्चन बहुत अच्छा था बच्चों, ध्यान रखेंगे. What do you mean by this statement? Light year is the distance traveled by the light in 1 year. Light minute is the distance traveled by the light in 1 minute. Okay? Is that very very clear? So, आपको कुछ नहीं करना था, आपको ये डिस्टेंस मीटर में कन्वर्ट करना था. तो लाइट मिनट में 8.33 को आपने मिनट्स में कन्वर्ट किया एंड देन यू मल्टीप्लाइड इट विद द स्पीड एंड यू गॉट द डिस्टेंस. Is that very very clear? चलो, so this brings us to the end of this lecture, and most importantly we have completed all the numericals related to SI unit and SI system. In the next lecture we are going to study vernier caliper, measurement of length by vernier caliper. एक लेक्चर हम वर्नियर कैलिपर पे करेंगे, एक लेक्चर बच्चों हम लोग स्क्रू गेज पर करेंगे. तो स्टे ट्यून्ड. एंड अगर अभी तक आपने सेशन लेक्चर को लाइक नहीं किया है, चैनल को सब्सक्राइब नहीं किया है, तो फटाफट से सब्सक्राइब कर लो. टिल वी मीट नेक्स्ट टाइम, टेक वेरी गुड केयर ऑफ योरसेल्फ. थैंक यू.